Hi, this is a video explanation of problem number 1 from homework number 2. I'm not going to include the other two problems from homework number 2 because I felt that most of you did pretty well on it, and also I included more commentary on those problems when I handed back your homeworks than on this one. This one a lot of people had trouble with, so I wanted to say some things about it specifically. So here it is, and on the next page we'll just look at part A. Alright, so part A. So the first thing to ask is, what does the proposition really mean? That's always the first thing to ask about any mathematical proposition that you're trying to see whether it's true or false. So, the beginning, there exists an x in the set 3, 6. First of all, what is this set 3, 6? And it's really just the set of numbers consisting just of the numbers 3 and 6. Not the numbers between 3 and 6. We're not including 4 or 5 or pi or 5.5, just 3 and 6. Okay, so that's our set. It's a very small set of 2 elements. Alright, so there exists a number a number that's either 3 or 6, such that if x is even, then x is bigger than 10. So, you just need to test the proposition for 3, and if it doesn't work for 3, then you can test it for 6. And if it works for either one of those, then you're good, because existence just means that there has to be something in the set for which it works. Okay, so testing it for 3. So that would mean that we're testing the following proposition. 3 even implies 3 bigger than 10. Okay, now a lot of you looked at this and said, oh, well, 3 is obviously not bigger than 10, so this has to be false. But remember what an implication means. An implication can only be false if the premise is true and the conclusion is false. And since the premise here is false, 3 is not even, this statement is true. Therefore, there exists a number between 3 and 6, such that if x is even, then x is bigger than 10. Namely, it works for 3, and therefore this statement is true. Counterintuitive though it may be, literally this statement is true. There is an element between 3 and 6 such that if x is even, then x is 10. Namely, if 3 is even, then 3 is 10, because 3 isn't even. Alright, let's pause on that for a second. Then we'll go to the next part. Okay, a useful denial of the proposition there exists an x in 3, 6, such that if x is even, then x is bigger than 10. So, we'll do this in a sequence of logical steps. First step, we'll just write down the negation. Alright, nothing much to that. Next step, we will do the standard transformation of changing a not exists to for all not. And finally, so that's what it looks like, and finally we will negate the implication statement by turning it into an and statement with the premise intact and the conclusion negated. Or in words, for all, or I guess I should say, for both of the numbers 3 and 6, for both of the numbers x in 3 and 6, x is even and less than or equal to 10. And you'll see I've written it up here. And decide whether that is true or false. Well, for it to be true, that would mean that for both of the numbers 3 and 6, for x set equal to those, they both have to be even and less than or equal to 10. Now they're both less than or equal to 10, but 3 is not even. So the universal statement, right, that's a harder toe to row than an existence statement typically, is false for one of the elements of the set. Hence, this useful denial is in fact a false statement. Because for a universal statement to be true, it has to be true for all the elements of the set, and this is not true for x equals 3, because 3 is not even. Thank you.